All right, let's talk about one of the most critical parts of building really resilient applications in Kubernetes: health checks. Honestly, this is the secret sauce behind Kubernetes' whole self-healing magic. So let's get right into it. This right here is the fundamental question. It seems simple, but it's everything. In the old days, we'd just check if a process was active, and if it was, hey, we'd call it a day. But for the complex distributed apps we build now, that's a super dangerous assumption to make. And this really captures that huge shift in thinking. On the left, you've got the old way. Process is running, we're good. But that method is completely blind to what I call zombie applications. The process is there, but inside, it's totally deadlocked, completely useless. The Kubernetes way, on the right, is so much smarter. It totally decouples the existence of a process from its actual health. It goes straight to the source and asks the application, hey, are you okay? Can you actually do your job right now? So how does Kubernetes actually ask these questions? Well, it uses this awesome toolkit called probes. Just think of them as an automated doctor, constantly checking the vital signs of every single one of your applications. Let's meet the three main types. Each one has a very specific job. First up, we have the Liveness probe. This is your defibrillator. It is the absolute last resort. It's designed to answer one question. Is this application so fundamentally broken that the only solution is to kill it and start over? If this probe fails, Kubernetes just steps in and restarts the container. It's for those catastrophic, unrecoverable failures, like a total deadlock where the app can't make any progress at all. Next is the Readiness probe, and this is more like a triage nurse. Its job is not to kill the application. Instead, it manages the flow of traffic. It asks, hey, are you ready to take on new work right this second? And if the answer is no, maybe it's still booting up or it's temporarily overwhelmed, Kubernetes just stops sending it new requests. The pod is still running, it's perfectly fine, it's just taken out of the traffic rotation for a little while to catch its breath. And finally, there's the startup probe. Think of this one as a post-op checkup. It's specifically designed for applications that take a long time to start. We've all seen them, those big, heavy Java monoliths that need a minute or two to warm up their caches and get going. This probe gives them that time. And here's the key part. The Liveness and Readiness probes don't even start until this startup probe passes. This is what prevents Kubernetes from getting impatient and killing a perfectly healthy but slow application while it's still booting. So let's just put it all together here. Liveness is your restart button for broken containers. Readiness is your traffic controller. And startup is the protector for slow starters. You can see they each have a really distinct, important role. That's why you almost always want to define both Liveness and Readiness probes, because they're solving two completely different problems. Okay, so we get what the probes are for, but how do they actually work? How do they ask the application if it's healthy? And more importantly, how can we tweak their behavior? Let's dive into the mechanisms and the parameters. So Kubernetes gives us four main ways to check on things. By far the most common is an HTTP GET. It's perfect for any web service. You just give it a health endpoint like /healthseas, and if it gets a successful status code back, everything's good. A TCP Socket check is even simpler. It literally just tries to open a connection on a port. Then you've got Exec, which lets you run any command you want inside the container. It's super powerful, but can be a bit heavy. And for more modern apps, there's a native, highly efficient gRPC check. Now, beyond just how we ask, we have a bunch of parameters that control the timing and sensitivity of these checks. And let me tell you, getting these right is the key to a stable system. Getting them wrong, well, that can cause a whole lot of chaos. These are the four big ones you're going to be using all the time. First, periodSeconds. That's just how often to run the check. Then, timeoutSeconds. How long Kubernetes will wait for an answer before giving up. Next, failureThreshold. This is how many times the probe has to fail in a row before Kubernetes actually does something about it. And finally, initialDelaySeconds, which is just a grace period. It tells Kubernetes to wait a bit after your app starts before it runs the very first check. Okay, I need you to pay close attention to this one. That timeoutSeconds, it defaults to 1 second. And that 1 second default is a classic trap. Seriously, for any application written in a language with garbage collection, like Java or even Python, a brief pause to clean up memory can easily take longer than 1 second, especially if the app is under heavy load. And what happens? A perfectly healthy application fails its check and gets needlessly restarted. The big takeaway here is be very, very careful with this default. It's often too aggressive. And that brings us to maybe the most important principle of all when you're setting up health checks. First, do no harm. It is surprisingly easy to configure a probe that, with the absolute best of intentions, can actually bring your entire system to its knees. This is what we call a cascading failure. Let me just walk you through this horror story. Step 1. Your central database has a tiny, temporary 30-second glitch. No big deal, right? But Step 2. A well-meaning developer configured the Liveness probe to check the database connection. So Step 3, because the database is down, every single one of your application pods fails its Liveness check and gets restarted by Kubernetes. Step 4. The database comes back online. But then Step 5, it is immediately hammered by hundreds of pods, all trying to reconnect at the exact same time, and it crashes again. And just like that, you're in a self-inflicted death spiral. A tiny glitch has caused a system-wide outage. So the moral of that terrifying story is this. Liveness probes must be shallow. They should only check the internal state of the application itself. Is the web server listening on its port? Has the main thread deadlocked? That's it. They should never, ever check external dependencies like databases or other microservices. If a database is down, you want your application to stay alive and handle that error gracefully, not get constantly restarted, making the problem 1,000 times worse. Okay, enough of the horror stories. Now that we know what not to do, let's talk about how to combine all these tools to build a pod that is truly resilient and ready for production. Now here's a pro-level tool for you, the pre-stop hook. This little thing is magic for achieving zero downtime deployments. See, here's the problem it solves. When a pod gets terminated, there's a bit of a race. The pod is shutting down, and at the same time, the network rules across the whole cluster are being updated to stop sending it traffic. A pre-stop hook solves this race by telling the pod, hey, before you shut down, just wait for, say, 10 seconds. This gives the network plenty of time to catch up, ensuring no new connections are sent to the dying pod. It's the key to a truly seamless, zero downtime rolling update. And this right here brings all of our key takeaways together. These are the golden rules. Always use both Liveness and Readiness probes. Always. Keep your Liveness probes shallow, no external checks. Use startup probes for any app that's a slow starter. Be careful with your timeouts. Bump them up to a safer value, like 5 seconds. Use those pre-stop hooks for graceful shutdowns. And finally, try to use the more efficient HTTP, TCP, or gRPC probes instead of Exec whenever you can. If you follow these rules, your applications will be so much more resilient. So I'm going to leave you with this one question to think about for your own systems. Take a hard look at your current configurations. Are your health checks truly building resilience, really enabling that self-healing power? Or are they a ticking time bomb? Just a self-destruct button waiting for the right dependency to have a bad day? As we've seen, the difference between the two is all in the details. Thanks for joining me.